I'm also fine. Thank you so much, JNV Khamam. All right. So we have been discussing complex number for last couple of lectures. And in the previous lecture, we have covered the properties, few properties, I would say, few properties of modulus. Like modulus of a complex number is always more than or equal to 0. Modulus of a complex number z is always greater than the real part of z. Similarly, modulus of z is always greater than or equal to imaginary part of z. Similarly, magnitude of z is also magnitude of minus conjugate is also magnitude of minus z is also magnitude of minus z bar. With this thing, I have also told you that if this is your complex number z, its image in the x-axis will be z conjugate. And the point right opposite to it with respect to origin is minus z, and its image in the x-axis is minus z conjugate. All right, that means all the points are lying on a circle whose center is origin and whose radius is magnitude of z. So that is why we have magnitude of all of them as same. Understood? And the most important, I also mentioned very important property that magnitude of zz bar is magnitude of z ka z square. All right. Then I told you about these properties that I'll explain these properties in the next lecture. So now I will start with this. Say you have z equals to r1 cos theta 1 plus iota sin theta 1. In the polar form, I can write it r1 e to the power iota theta 1. Agreed? Now I have another complex number z2, that is r2. So it is cos theta 2 plus iota sin theta 2. So it can be written as r2 e to the power iota theta 2. Am I clear? Now if I multiply both of them, z1, z2, that would be r1, r2 e to the power iota theta 1 into e to the power iota theta 2. Fair enough? So that is r1 r2 e to the power iota theta 1 plus theta 2. So that is r1 r2 cos theta 1 plus theta 2 plus iota sin theta 1 plus theta 2. Am I correct? Now, do you realize that magnitude of z1 z2 is going to be r1 into r2? That is magnitude of z1, magnitude of z2. Am I clear? And argument of z1, z2 is, if you see here, what is the argument? Argument is theta 1 plus theta 2. And that is what? Argument of z1 plus argument of z2. Am I clear? Similarly, if you divide both, say z1 upon z2, have a look at it. This is very good and nice property. Understood? Now, if I divide both of them, I get r1 upon r2 e to the power iota theta 1 upon e to the power iota theta 2. That is r1 upon r2 e to the power iota theta 1 minus theta 2. Got it? So magnitude of z1 upon z2 is very clearly, it is here r1 upon r2. That is magnitude z1 upon magnitude of z2. Am I clear? Similarly, if you see, argument of z1 upon z2 is what? That is theta 1 minus theta 2. This is going to be the argument. And that is what? Argument of z1 minus argument of z2. Understood? So with this, I can say that this magnitude of Z1, Z2, see this property, magnitude of Z1, Z2 is what? Magnitude of Z1 into magnitude of Z2. Or in general, if there are more complex numbers, then magnitude of Z1, Z2, Z3 up to Zn is magnitude of Z1, magnitude Z2 up to magnitude of Zn. Similarly, magnitude of Z1 upon Z2 is magnitude Z1 upon magnitude Z2, and magnitude of Z to the power n is magnitude Z raised to the power n, where n belongs to integer. Understood? Similarly, there are few more properties of modulus. I have given proof of them also. If you see, magnitude of Z1 plus Z2 whole square is mod Z1 square plus mod Z2 square plus Z2 Z1 bar plus Z1 Z2 bar. Very important. And magnitude of Z1 minus Z2 whole square is mod Z1 square plus mod Z2 square minus Z2 Z1 bar plus Z1 Z2 bar. Fair enough? So now see, I have given proof of that also. That is magnitude of Z1 plus Z2 whole square is, you can write Z1 plus Z2 into mod Z1 minus mod Z2. So it is Z1 Z1 bar, Z1 Z2 bar, Z2 Z1 bar, Z2 Z2 bar. Got it? So conjugate of each other. So that means Z1 plus Z2 magnitude square is mod Z1 square plus mod Z2 square plus 2 real part of Z1 Z2 bar. And similarly this one. Got it? Now, this is what we call triangle law inequality. Properties of modulus. This is what we call triangle inequality. What is a triangle inequality? That magnitude Z1 minus magnitude Z2 mod is less than equals to. See, the triangle inequality states, let us assume this is a complex number Z1. Say this is y-axis and this is x-axis. Understood? This is x-axis, this is y-axis. So if this is Z1, this is Z2. Now if I complete this triangle, this point will be what? This point will be Z1 plus Z2. Now if you see, this is mod Z1, this is mod Z2, so this is also mod Z2. And this is going to be what? Magnitude of Z1 plus Z2. So if this triangle will be existing, that means sum of two sides is always greater than the third one. Am I clear? Sum of two sides, mod Z1 plus mod Z2 is always greater than the third one. Now, if this is Z2, and definitely, if I replace Z2 by minus Z2, I get this thing. So, sum of two sides is always less than the third one, greater than the third one. And also this is more than mod, difference of two sides is less than the third one. So I'm using that property that difference of two sides is always less than the third one. Got it? Similarly, in this inequation, if I replace Z2 by minus Z2, I get this inequality. Got it? If you want to make a triangle here also, in that case, what you can do, say this is minus Z2. Now, complete the parallelogram, join this, and this becomes Z1 minus Z2. Understood? So, say, let's take a question over it. Just a moment, just a moment. Now, let's take a question on it, triangle inequality. The question is, given magnitude of Z1 is 3 and magnitude of Z2 is 5. Find the range of magnitude of Z1 plus Z2. Now, if you see, this is an easy treat. You just need to apply directly the inequality. So magnitude of Z1 plus Z2 is less than or equals to mod Z1 plus mod Z2. It is more than or equals to mod Z1 minus mod Z2 modulus. So magnitude of Z1 plus Z2 is less than or equals to 5 and 3, 8, and it is more than or equals to 2. Got it? But we will do another problem, little bit of better problem. Given magnitude of Z1 minus 1 less than equals to 1, magnitude of Z2 minus 2 less than equals to 2, and magnitude of Z3 minus 3 less than equals to 3. Now they are asking you find the greatest value of magnitude of Z1 plus Z2 plus Z3. Yes, give it a try. Find the greatest value of Z1 plus Z2 plus Z3. Tell me the answer, anybody? Dhruvi? Now see, this magnitude of Z1 plus Z2 plus Z3. It can also be written as magnitude of Z1 minus 1, Z2 minus 2, Z3 minus 3 plus 6, which is less than or equals to magnitude of Z1 minus 1 plus magnitude of Z2 minus 2 plus magnitude of Z3 minus 3 plus 6, which is less than or equals to 1 plus 2 plus 3 plus 6, which is equals to 6 and 3, 9 and 2, 11 and 1, 12. This is the answer. Understood? So that means magnitude of Z1 plus Z2 plus Z3 can have a maximum value of 12. Very good question. Very good. Got it? Now let's take another example. This example is also there in NCERT. If Z1 magnitude is Z2 magnitude is Z3 magnitude is 2, find the value of magnitude of 1 by Z1 plus 1 by Z2 plus 1 by Z3 if given magnitude of Z1 plus Z2 plus Z3 is 3. Yes, give it a try. Now see, from this information, if I take magnitude of Z1 square is 4 That means Z1 bar is 4. That will also be equals to Z2 bar. That will also be equals to Z3 bar. Agreed? Now, given to me is magnitude of Z1 plus Z2 plus Z3 conjugate. Z3 is 3. That means magnitude of Z1 plus Z2 plus Z3 conjugate is also 3. That means magnitude of Z1 conjugate plus Z2 conjugate plus Z3 conjugate is also 3. All directly derived from the properties of conjugate. Now this Z1 conjugate can be replaced as 4 by Z1 plus Z2 conjugate again 4 by Z2. Z3 conjugate upon again 4 by Z3 is given as 3. That means magnitude of 1 by Z1 plus 1 by Z2 plus 1 by Z3 is 3 upon 4. Am I clear? This is 3 upon 4. Now, let's do another question based on sort of similar concept. But the question is, if magnitude of Z1 is 1, magnitude of Z2 is 2, magnitude of Z3 is 3, and magnitude of 9Z1 Z2 plus 4Z1 Z3 plus Z2 Z3 is equals to 12. Find the value of magnitude of Z1 plus Z2 plus Z3. Yes, give it a try. Yes, please, quick. Mod Z1 is 1, mod Z2 is 2, mod Z3 is 3. And magnitude of 9Z1 Z2 plus 4Z2 Z1 Z3 plus Z2 Z3 is 12. See, can I say that Z1 conjugate is 1, Z2 conjugate is 4, and Z3 conjugate is 9? Yes or no? Now, another thing given to me is magnitude of 9Z1 Z2 plus 4Z1 Z3 plus Z2 Z3 is 12. Let's do one thing. Let us replace this 9 by Z3 conjugate. Replace this 4 by Z2 conjugate, and replace this 1 by Z1 conjugate Z2 Z3 mod is equals to 12. Understood? Now from all of them, if you realize this Z3 Z1 Z2 Z2 Z1 Z3 Z1 Z2 Z3, that can be taken common. So that means magnitude of Z1 Z2 Z3 into Z1 conjugate plus Z2 conjugate plus Z3 conjugate is 12. So that is mod Z1 into mod Z2 into mod Z3 into mod Z1 plus Z2 plus Z3 conjugate is going to be 12. Am I clear? Now mod Z1 is given to you 1. mod Z2 given to you 2, mod Z3 given to you 3, magnitude of. Now Z1, Z2, Z1 plus Z2 plus Z3 conjugate. Modulus of that is also equals to modulus of Z1 plus Z2 plus Z3, that is 12. So that means magnitude of Z1 plus Z2 plus Z3 is 12 upon 6, that is 2. Have a look. Understood? Now, let's go for another very good question. The question is, if magnitude of Z minus 5 plus 7 iota mod is 9, then find the greatest and least value of magnitude of Z minus 2 minus 3 iota. Yes. Students, please be quick. Yes. So see, we are looking for magnitude of Z minus 2 plus 3 iota. So how I can write it? I can write it magnitude of Z minus 5 plus 7 iota plus 3 plus 4 iota. I can also write it like this. Z minus 5 plus 7 iota plus 3 plus 4 iota. Now consider this whole as an identity. So it is less than or equals to, or I should write it like that, magnitude of Z minus 5 plus 7 iota plus 3 plus 4 iota less than equals to Z minus 5 plus 7 iota mod plus magnitude of 3 plus 4 iota, and it is more than or equals to Z minus 5 plus 7 iota mod minus magnitude of 3 plus 4 iota and complete mod of this. So say this is expression E. So that means E is less than or equals to, this is 9 and this is 5. All right. And this E is more than or equals to, this is 9 minus 5 mod. So this E lies between 4 to 14. This is your answer. Got it? Now, let's do another very good question. So the question is given magnitude of z minus 4 upon z is 2. Find the greatest and least value of, find the greatest and least value of magnitude of z. Yes, give it a try. Magnitude of z minus 4 upon z is given as 2. Find the greatest and least value of mod z. Yes, quickly try. Only one property is what we are going to do, that is triangle inequality that we have done today. That's a magic property, magic I tell you. See, how do I do it? Magnitude of z minus 4 upon z mod. This will be less than or equals to mod z plus 4 upon mod z. And this is more than or equals to mod z minus 4 upon mod z magnitude. Yes or no? Now let us put magnitude of z as r so that I don't have to write it again and again. So this is 2 less than or equals to, it is r plus 4 upon r. It is more than or equals to 2 less than or equals to r plus 4 upon r. It is more than or equal to r minus 4 upon r. Understood? Now, if I go with this part of inequality, so this is going to be 2r more than less than or equals to r square plus 4. That means r square minus 2r plus 4 more than or equal to 0, which is always true. Because its d is negative, so this part is always true. Now let's come to this part. So from this I can say r minus 4 by r, it is more less than or equals to 2. It is more than or equals to minus 2. Multiplied by r. So minus 2r less than or equals to r square minus 4 less than or equals to 2r. Again, this inequality goes two way, either this way or this way. So if I go this way, I get r square minus 2r minus 4 less than or equals to 0. That means r lies between the roots and roots will be 1 plus 1 plus root 5 and it is 1 minus root 5. So from this part, I get this. All right. Now, if you go with this part, you get r square minus 2r minus 4 plus 2r minus 4 more than or equal to 0. So from this part, I get r more than or equals to minus 1 plus root 5 or r less than or equals to minus 1 minus root 5. Now see, this won't exist because r cannot be negative. So from this, I can say r more than or equals to root 5 minus 1. Now you take intersection of both of them. So if I take intersection of both of them, r will be less than or equals to 1 plus root 5 and more than or equals to root 5 minus 1. Am I clear? R will be less than or equals to 1 plus root 5 and more than or equals to root 5 minus 1. So in the case of brackets, you can write it from root 5 minus 1 to root 5 plus 1. Got it? Now, little bit of properties of conjugate. Let's do as of now. We have already covered all these properties. See, if z equals to z conjugate means z is purely real number. Because only real numbers are there whose conjugates are not changing because there is no sign of iota. If z equals to minus of z bar, then z is purely imaginary number. Moreover, we remember this like this, that z plus z conjugate is 0. If z plus z conjugate is 0, means z is purely imaginary. Then z1 plus z2 conjugate is z1 conjugate plus z2 conjugate. z1 minus z2 conjugate is z1 conjugate minus z2 conjugate. z1 z2 conjugate is z1 conjugate into z2 conjugate. So you take the conjugate individually. And z1 upon z2 combined conjugate is z1 conjugate upon z2 conjugate. Definitely z2 should not be 0. Now, z conjugate, again conjugate is going to be z. Okay, you just have a look at it once. I think I'm running quite fast. Next, z to the power n conjugate is z conjugate whole to the power n. Fz conjugate is f of z conjugate. That means what? If equation is valid for a complex number, it is valid for its conjugate also, where f being a polynomial with real coefficients. Now again, they came with this property, which is very, very, very important. I told you, what did I tell you? That zz bar is magnitude of z whole square. Understood? Now let's do a question over it also. If z1 minus 2z2 upon, if z1 minus 2z2 upon 2 minus z1 z2 bar is unimodular, and magnitude of z2 is not 1, then find magnitude of z1. I repeat the question. If z1 minus 2z2 upon 2 minus z1 z2 conjugate is unimodular. Unimodular means its magnitude is unity. Understood? So, magnitude of z1 minus 2z2 upon 2 minus z1 z2 conjugate is unimodular, means its magnitude is 1. And definitely given to me also, mod z2 is not 1, means z2 is not unimodular. So they are asking for mod z1. Now, how do I do it? I will surely use properties of conjugate here. Understood? First of all, this square is going to be 1. Yes or no? Why so? Because if magnitude of this is 1, so magnitude of its square is also 1. So now I remember a property, mod z square is zz bar. Mod z square is zz bar. So I can write it z1 minus 2z2 upon 2 minus z1 z into its conjugate. So z1 bar minus 2z2 bar upon 2 minus z1 bar z2. This is going to be 1. Got it? Now let's cross multiply. So I will get z1 minus 2z2 Z1 bar minus 2Z2 bar is equals to 2 minus Z1 Z2 bar, 2 minus Z1 bar Z2. Yes or no? So it is Z1 Z1 bar minus twice of Z1 Z2 bar minus twice of Z2 Z1 bar minus 4 times Z2 Z2 bar. This is equals to, now it is 4 minus 2 times Z1 bar Z2 minus 2 times Z1 Z2 bar plus Z1 Z1 bar Z2 Z2 bar. So just use one property of modulus and conjugate, cross multiplied and then further multiplied. Now from here if you see, this term will cancel with this term. Yes or no? And this term will cancel with this term. Then what you are left with, this is magnitude of Z1 square minus 4 times magnitude of Z2 square minus 4 minus, this will come with the positive signs, plus this minus 4 minus Z1 magnitude square into Z2 magnitude square goes 0. Now from this and this, I take magnitude of Z1 square common, so you get 1 minus magnitude of Z2 square, and take minus 4 further common, you get 1 minus magnitude of Z2 square, that is 0. So it is Z1 square minus 4 into 1 minus Z2 magnitude square goes 0. Now they are already saying that magnitude of Z2 is not 1. That means this particular term is not going 0. That means magnitude of Z1 square is 4. So magnitude of Z1 is going to be 2. This is your answer. Am I clear? Magnitude of Z1 is 2. Very good question. Just take a look at it. Understood? Now let's go. Let's do another very good question. The question is, it is given that Z1 and Z2 satisfy mod Z1 is 2 and mod Z2 is 3. If angle between their corresponding vectors is 60°, then find the value of magnitude of Z1 plus Z2 upon Z1 minus Z2. Yes, give it a try. Yes, give it a try quickly. Dhruvi, Bacha, you are from which JNV? You may reply in the chat. Dhruvi, okay, JNV, Sabarkanta. Where is it? Is it in like Pune region or Hyderabad region? No. So I have seen your process is very good in AITs. So is there anything extra we can do for you so that you can improve even further? Hmm? Dhruvi? So that you can improve further. Can you switch on your camera once? And your mic also?
Yes.
Yeah, Dhruvi, can you switch on your camera? It's asking you, can we do something extra for you so that we can see more improvement in your performance? Yes, you may reply in chat box only if you are not able to switch on the camera. See, first of all, let me explain this question. Papagio. So, let me explain this question. Magnitude of Z1 plus Z2 is under root of, I can write magnitude of Z1 plus Z2 whole square. That is under root of magnitude of Z1 square plus magnitude of Z2 square minus 2 times mod Z1 mod Z2 cos 120. So how did I get this? Say, if this is mod Z1, this is your mod Z2. They are saying angle between them is 60 degree. Now, if you complete this parallelogram, then this is what? Mod of Z1 plus Z2. And this is what? Mod of Z1 minus Z2. Got it? So if I apply cosine law, you can use, then what do you say? This is under root of mod Z1 given 2 means 4 plus 9 minus 2 into 2 into 3 into cos 120. Agreed? So cos 120 is minus half, which cancels this and make this sign positive. So what it is? 9 and 4, 13 plus 6. That is under root of 90. All right. Now, magnitude of Z1 minus Z2 is under root of mod Z1 square plus mod Z2 square plus 2, minus, yes, mod minus of mod Z1 mod Z2 into cos 60. So it will be under root 4 plus 9 plus minus, it will come out to be 6. Got it? So it will be under root of 7. So magnitude of Z1 plus Z2 upon Z1 minus Z2 mod is mod of Z1 plus Z2 upon mod of Z1 minus Z2, that is 19 by 7 under root. Understood? So this was an easy treat. Am I clear? So Dhruvi, what I was asking you, can we do something for you so that your performance improve or we can get better results out of you? This is what I was asking you. Can you switch on your mic? All right. I think you might not be in a good network area. So that would be all from my side for today. So that would be all from my side today.